In this demo, we will use NSWAG Studio to generate DTOs for our client. Let's install NSWAG Studio first. We're looking at the NSWAG repository over on GitHub. Here you can download and install NSWAG Studio. I already did that on my machine, so let's launch it. On the left, we can define things having to do with input. That would be our Swagger definition file. On the right, we have lots of options for output. Let's start with input. We can generate DTOs from an assembly, from a JSON schema, from ASP.NET Core API Explorer, and so on. In our case, we are mimicking an API of which we don't know what it was written in. All we have is that OpenAPI definition file. So let's input the URL to that. Make sure that the API is up and running in the background for this to work. Then let's click Create Local Copy. There we go. What we want to generate is a C# client. So let's check C# client. And let's click the tab. Here we can configure what exactly will be generated how. Let's start by inputting a namespace for our DTO models. We'll again use movies.client.models, just like we did in the previous demo. We only want to generate DTO classes. NSWAG Studio can potentially generate more. It can also generate a client to integrate with an API using those DTO classes. But using those implementations means we're hiding a lot of the details we want to learn about. Moreover, they don't really follow best practices and tend to go for the simplified approach. So I prefer not to use them. We just saw that in the previous demo actually. So let's uncheck Generate Client Classes. And let's scroll down a bit. We do want to generate DTO classes. And for those, there's also a lot of options we can choose. Most of them are not needed for our purposes. I prefer these DTO classes to be as plain and simple as possible, as they only serve one purpose. They're there for transferring data across the wire. So let me uncheck all of these options that would result in additional classes or annotations being generated. Depending on your architecture, for example, when you reuse those DTO classes for other purposes, your requirements may vary. But the nice thing is that NSWAG Studio will almost certainly serve your needs. One thing that is important to look into is the class style we want to generate. The default is POCO, or plain old CLR object. That's the simplest format, which is what we need. You can also generate classes which throw iNotify property change definitions, which is very convenient when working with a Xamarin client. Other variations are possible as well, but we're okay with POCOs. Up next is selecting the JSON library to use for serialization. As mentioned before, system.text.json is Microsoft's built-in serializer, but support for that in NSWAG Studio is experimental at the moment of recording, so we will use JSON.NET, which is Newton, which is the same as Newtonsoft JSON. That's it for now. Let's click Generate Outputs. And let's have a look. We now see the generated output. A movie class, a movie for creation, a movie for update, and so on. Exactly as we saw when we looked at the Swagger documentation. If you're not okay with how these classes look, it's just a matter of changing an option on the settings screen and generating output again. I'm quite happy with how they look, but there's a few classes and interfaces that have been generated that shouldn't be generated. Operation type, an enumeration, is one of those things. But there's more, like iContractResolver and a few other ones. These are all generated because our API supports partial updates. We will learn about that later on in the course. For now, just know that these classes are not needed. There's full support for partial updates, we don't need generated classes. So let's open the settings and let's scroll down a bit. And let's add these classes, which are operation type, iContract resolver, movie for update JSON patch document, and movie for update operation to the excluded types list. Alright, let's click generate output again. And there we go, they're gone. Now let's add these to our project. Back to settings. Let's scroll down a bit. Down here we find the output file path field. Let's click the three dots here and let's navigate to our movies client. Let me add a models folder here. And let's name the file that's gonna be generated DTO models. Alright, let's click save and let's click generate files. Generation is complete. Let's click OK and let's switch to Visual Studio. We're looking at our movies client and we see that indeed a models folder with the generated DTO models has appeared. These are now part of our project. Important to notice here is that you see that all the properties are annotated with newtonsoft.json.json property annotations. These tell JSON.NET something in regards to how to handle serialization and deserialization. It works and compiles because a NuGet package reference to JSON.NET was added when in the previous demo we added a connected service reference. If you skipped that demo, don't forget to add the newtonsoft.json NuGet package yourself. As mentioned before, we will start with Microsoft's built-in serializer. That one will simply ignore these attributes. I can now also get rid of showing all the files in our UI. We don't need that anymore. That's it. Now let's have a look at how we can tackle integration with HTTP client. What you see on screen is a very basic example of using an HTTP client instance to fetch a list of movies. It uses Microsoft's built-in system.text.json deserializer. I'm sure this will look familiar to quite a few of you. If it doesn't, don't worry. All will become clear during this course. But before we're going to write actual code, it's important to understand what HTTP client is and how it works. In other words, what does this code do? We're working with HTTP, which is a request-response protocol between a client and a server. A client submits an HTTP request to the server, and the server responds with a response to the client. We use it constantly in our daily lives when surfing the web, for example. So, a good way to start is by having a look at the web. A browser is also a client that can send HTTP messages and capture responses. I've got Chrome opened here. Let's open the DevTools by pressing F12. What we want to do now is surf to a site. I'm going to use my own personal site as an example, but any site will do. I've got the DevTools network tab opened here, so that's good. Let's now press Ctrl F5 to fully refresh this page. And there we go. We see a set of requests here. Let's open one. The browser sent a GET request to kevindocs.com. It included a set of request headers in that request. These define the operating parameters of an HTTP transaction. For example, by setting the accept header, the browser stated the format of the response it wants to accept from the server. And then the server responded with an HTTP response message. And that one also has its set of headers, the response headers. For example, the content type header here tells the client what the type of content of the message body is. From that, the client can know how to parse that content. The client in this case is the browser, and the message body in this case is the HTML code of my home page. The response also contains a status code, 200. That states that the request was successfully handled. There's a variety of status codes that exist. A 404 tells the client that a resource wasn't found. A 500 tells the client that an internal server error happened. And there's many more. It's from these status codes that the client can know if a problem happened or not, and when it happened, how it can potentially solve it, if at all. We can, by the way, also use that browser to send requests to our API. Our API is up and running in the background. Let's open another tab pointed to the movies endpoint. And let's open the DevTools again and send this request again. We see two results. A 404, that means not found, because the browser tried to get a favorite icon and we haven't specified that. And the second request is one with status code 200. That seems to have worked. If we look at the response, we see the response body contains our movies. Yet, when we want to integrate with an API from code, we don't have a browser at our disposal. Well, theoretically we could probably fire one up in some cases, but that is clearly not a good practice. And that is where HTTP Client comes in. HTTP Client is the go-to class for sending HTTP request messages and receiving HTTP response messages. Through HTTP Client, we can send a GET request to get API/movies, and we can catch the response. The object used to hold such a request is an HTTP request message, and the object in which the response is encapsulated is an HTTP response message. But how does it do this? How does HTTP Client handle sending these requests and receiving these responses? Well, it does that through message handlers. These are implementations of the HTTP message handler class. Such a handler is an object that accepts an HTTP request message and returns an HTTP response message. But how exactly that happens is dependent on the implementation. Not all handlers have to actually send requests over the network. We could, for example, have a handler that does nothing more than manipulate one of the request headers. Socket's HTTP handler is the default handler used by HTTP Client in .NET. And that one does actually send a request over the network and returns the response it gets from the server. Often though, a series of message handlers are chained together, resulting in a pipeline. The request is received by the first handler in the pipeline, potentially does some processing and passes the request on to the next handler in the pipeline. Eventually, a response is created and travels back up the pipeline. This pattern is called a delegating handler. The socket's HTTP handler is typically the last one in that chain, as that one actually sends a request over the network. But any of the previous handlers can decide not to pass on the request to the next handler. A good example is a caching handler, which would inspect the request, check if a previously stored response is available, and if it is, return that response. And if it is, returns that response, instead of passing through the request to the socket's HTTP handler. By the way, before .NET Core 2.1, the default handler was the HTTP Client handler. It's been surpassed by the faster, cross-platform socket's HTTP handler ever since. So this is the high-level overview of how HTTP Client works. In the next module, we'll start using it. For now, it's time for the module summary.